Good morning. Peace be upon to you. I'm really very honored and thankful for being here today. This is Fatema Tuz Zohora, ID 1913015, Department of Chemistry, Begum Rocky University, Rangpur. So what I want to do today to give you the information about viscosity, viscosity coefficient, effect of temperature, pressure on viscosity. Okay, as I mentioned the first thing, I'm going to talking about viscosity. Viscosity of fluid is a measure of its resistance to gradual deformation by shear stress and tensile stress. It's also known as internal friction on a moving fluid. Here we know viscosity is a measure of a fluid's resistance. Water has lower viscosity for being lower density, whereas honey has the higher density and higher viscosity. Besides water and honey, here we can see that water, milk, oil, light syrup, heavy syrup, chocolate syrup, which have sticky, thick, vigorous, and bonding stronger. The mathematical terms of viscosity is shearing stress by velocity gradient. The SI units of viscosity is Pascal second, and the common unit is dynes per second, which is known as poise. Let me move on the second item, which is viscosity coefficient. Coefficient of viscosity is the force of friction required to maintain velocity difference in 1 centimeter. Viscosity coefficient can be defined in two ways. One is dynamic or absolute viscosity, and the other one is kinematic viscosity. Viscosity is a tensorial quantity that can be decomposed in different ways into two independent components. The most usual decomposition yields the following viscosity coefficient is shear viscosity, external viscosity. Here the first one, dynamic viscosity, is the relationship between the shear stress and the shear rate in a fluid, which we know as absolute viscosity. Besides, in kinematic viscosity is the relationship between the viscous and the inertial force in a fluid. Our third item is the effect of temperature. The viscosity of liquid decreases with the temperature, whereas the viscosity of gases increases with the increases of temperature. Temperature effect of the viscosity in materials here, when liquids is heated, viscosity decreases, and when liquid is cooled, viscosity increases. Besides, when gases is heated, viscosity increases, and the gases is cooled, viscosity decreases, which is the vice versa of liquids. We can see the graph between viscosity versus temperature. Here, two items, water and glycerol, are used, and the curve says as the graph says as the curve. And our last item is effect on pressure. Lubricant's viscosity increases with pressure, and the viscosity versus pressure shows us the straight line graph, where we can use oxygen, hydrogen, nitrogen, carbon dioxide, sulfur dioxide, and so on. So is viscosity and coefficient of viscosity same? No, they are totally different. Do you have any question about my presentation? I want to thank you once again for being here today and give me the opportunity for this space. Thank you.